This is example 1 for the additional mates and sub-assemblies lesson. Starting point files are required. To begin example 1, we again need to start a new assembly file, so select New and select Inch Assembly. And now with our Inch Assembly file open, we can browse to find our first component. Our first component will be located within the example 1 folder, and it is the starting point file 1. So select Open. Select the thumbtack to keep this window visible, and then drop our part on the origin, simply selecting OK. Next, select Browse, and go through, and we will select the remaining components using the Browse tool and dropping each one of those remaining components in our graphics area. Once we've dropped all of the components in our graphics area, we can press Escape to get out of the Browse Component command. We are now ready to begin mating these parts together. Some of the mates will be similar to ones we've used before, and other mates will be new. Again, we'll add our mates by using the Q keyboard shortcut. And I'll start by mating the cylindrical face of this screw to the cylindrical face of the hole in the vise body. In my case, it's gone in the correct orientation, so I can select OK. Next, I'll locate the hole in the vise jaw to the cylindrical face of the screw. Again, I need to verify that it's gone in the correct orientation, and it has, so I can select OK. Next, I'll mate the bottom of the vise jaw to the bottom of my vise. Please note I've drawn this with 0 clearance, but had you drawn it with clearance, you would not be allowed to make the bottom of that vise jaw coincident with the bottom face of the vise base. So you would have to use the parallel mate instead of the coincident mate. Next, I'll mate my screw into the hole in the bottom of my vise jaw, and I can then mate the bottom of that slot for the screw to the locating face on the screw. You can see my screw is now jumped into my vise jaw, and the next step will be to select the face of that screw, and this time I'm going to select a flat face instead of a cylindrical face, and we'll create a tangent mate. What this is doing is forcing the edge of that cylindrical face to be tangent to the flat face of that screw. With that selected, I can select OK, and then I'll add a concentric mate to my handle. Now, many of those mates are mates that we've done before, with the exception of tangent. And now we're ready to begin some of the newer mates. What we'll be doing is the distance mate. So if I select the two faces that would touch together when the vise is completely closed, you can see I can either set a distance and enter a value for the jaw to be open, but this would fix that jaw in that location, and really a vise can open and close. So instead, I'm going to go to my Feature Manager area and select the Advanced Mates drop-down. Within this, I can have an Advanced Distance Mate. So instead of simply defining how far apart those two faces are, I can actually define the minimum and maximum travel values. The minimum is obviously 0. That jaw can go right up to touch the face. And the maximum we're going to enter at 1 3/4. Now you should note the current dimension has to fit within the minimum and maximum values. And this is important because sometimes your vise will currently let's say your jaw is sitting way out here. I'm going to put it even farther out. Let's say when you start that mate, the jaw is way out where it shouldn't be. I am not allowed to enter a maximum value of 1 3/4. I first have to move this dimension to within the travel that I'm looking for, and then I can apply a maximum travel that maintains the current dimension within that travel. Anyway, with our travel set, we can select OK. And now we'll see, without having physical dynamics, our vice jaw moves within that given travel. This just speeds up the computing time. The computer doesn't have to think about whether or not it's running into another part because we've defined with mates its travel. Now another method of mating is to mate with the planes as opposed to simply the faces. So what I'm going to do is select the little plus sign beside my assembly that's extended out into my graphics area, and then I'll select my handle and select the plus sign to expand that, and I'm going to select the side plane of that handle. Next, I'll find the main lead screw of my vise, expand it, and select the top plane. So again, the plane that slices through perpendicular through this part and is perpendicular to the hole that I'm mating. Let's see what it would look like with a coincident mate. That would lock that in center, but we know that that can travel back and forth. So instead, I'm going to activate an advanced mate. Again, a distance mate. This time having a minimum of -1. We need a current value of 0 and a maximum of 1. Again, noting that I had to bring that current value to within the travel that I was looking to set. And now I can select OK, and we will see that this handle is forced to stay within the travel that we've defined. And because there was no flat faces on this cylindrical object, we needed to use that flat plane to give us a face to dimension to. There are other reasons we'd use the flat plane. Oftentimes, if you want to center two objects that have clearance between them, you can mate them on the planes. This is another good reason for having your origin at the center of a part file. Then you have a plane that slices through the center of that part, and it gives you a mating reference to center it with other files. Well, that concludes this example, and I trust it was a help. This is exercise 1 for the additional mates and sub-assemblies lesson.